In last sessions, we studied about wave motion, wave, the classification of wave, and in detail we have studied about mechanical and non-mechanical wave. Today we will study about transverse and longitudinal wave. So let's start with wave motion sound. Basics we already know. So we have already discussed the classification of wave depending on the medium requirement, and that was mechanical and non-mechanical wave, or other word elastic or electromagnetic wave. Today we will discuss about the second point, that was the classification of wave depending upon the direction of vibration of medium. Classification of wave depending upon the direction of vibration of medium particles. So as per this, we can classify wave into two ways, that is, first is transverse waves, second is longitudinal wave. So now we'll discuss in detail about transverse waves. Transverse waves is a wave motion in which an individual particle of medium vibrates in a direction at right angle to the direction of propagation of wave, okay, and this is called transverse wave motion. The best example for this is transverse wave on a stretched string. Okay, and we can easily show the diagrammatic representation of transverse waves. Let's say we have a stretched string. On this string we have 4 points. As we give a small jerk towards one end of this string, okay, we will find that there would be a displacement in first particle along its mean position, and that displacement will be in the perpendicular direction, okay, come from perpendicular direction, and that perpendicular direction with the stretched string. So the displacement is follows. Gradually the energy will be passed on to the second particle, and then second particle will displace along its mean position, and so on and so forth. The energy will be gradually transfer to the next particle, and slowly the vibrations pass on to the next particle, and then next, and then next. So stretch string is example of transverse waves. Second, water ripple created on the surface of water is also example of the transverse waves, because if we can do that simple experiment at our home. You put a leaf or a thermocol small piece on a surface of a water tank, and if we drop a pebble, we'll see a concentric waves, circular loops creating as a wave on the surface of water tank. Okay, and we'll observe that the leaf or the thermocol piece is going just up and down. It is not traveling along the direction of wave. It is just going up and down. So the particle of water surface is traveling. My apologies. The particle of water surface is vibrating along their mean position, and the motion is directly perpendicular to the direction of wave motion. See, wave is this is water wave, or you can say water ripple on surface. Okay, so in transverse waves, if the wave is moving in positive, let's say x direction, then the medium particle vibrates in the direction which is perpendicular to wave propagation, and gradually the energy will be transferred from one particle to another. It will pass on from one particle to another. So this is transverse waves. Then we can observe this in given example as well. So in water wave, in the case of surface of water also, the individual particle of water oscillate in the direction at right angle to the direction of propagation of wave. Okay, and similarly in a heavy rope, okay, with one of the end is tied to a hook. Okay, and if we give a jerk at the free end, we can see that the wave is traveling along the length of the rope, but each part of the rope vibrates up and down. Okay, so this is the best example for that transverse waves. Next we have longitudinal wave. So the definition of longitudinal wave: a wave motion in which the particle of the medium vibrates about their mean position along the direction of propagation of the wave, and this will be called longitudinal wave motion. Example: sound wave in air. Second, wave in a slinky. So if we see in any instant at any point in the space where pressure and density is maximum, okay, and we will see that when sound wave is moving, okay, let's say sound wave in air move with the speed of 340 meter per second. when a longitudinal wave travels in a medium, then the particle of medium vibrates back and forth in the same direction in which the wave is traveling. So let's see, wave is traveling in positive x direction. The vibrations of medium particle, individual particle, will be in the same direction as that of wave. And the best example is sound wave in air. And in any instance where the pressure and density is maximum, that will be called compression, and at where the pressure and density is minimum, that will be called rarefaction. And the waves travel in the form of compression and rarefactions. Okay, the another example, if sound is created by a tuning fog, okay, we can give the diagrammatic representation of to this also as well. Let's say I have a tuning fog, okay, in rest, then a vibrating tuning fog. When it is vibrating, this is vibrating tuning fog. It is pushing the waves ahead. Then in second position, the dotted part is a equilibrium part, normal case, and the yellow line will show us the vibrating part. So, and we have the dash is dotted points, this is air particles. So in normal circumstances the density is equal. Then once the air particle near the tuning fog pushed by the arm of the tuning fog, then we can see the compression and rarefaction, and slowly the compression will change into rarefactions and rarefaction will change into compression, and we will see that wave is moving ahead in the form of these compression and rarefaction. Again, point to be remembered, the dotted part which I am drawing is a tuning fork at equilibrium. The blue line will show the vibrating part when it is vibrating, and the yellow dots is the air particles. So again compression will be created, so the rarefaction part will become compression, and then the area which is having compression will turn into rarefaction, and again the sound will move in the form of compression and rarefaction. So this is the example of longitudinal wave. Next time we will discuss about the transfer waves and longitudinal wave, the difference between them. Thank you.